Alert! Helium-4 gas at Yellowstone Supervolcano, indication of imminent eruption. Are you ready for a groundbreaking discovery about one of the world's most dangerous supervolcanoes? Yellowstone National Park scientists have discovered a rare gas that could be a critical warning sign of an impending eruption. In this video, we'll look at what this rare gas is, how it was discovered, and what it could imply for Yellowstone's future. Yellowstone Supervolcano. One of the world's largest volcanoes hides beneath Yellowstone National Park, a vast expanse of breathtaking wilderness visited by over 3 million people each year. The Yellowstone Caldera, the cauldron-like basin at the top of the volcano, is so big that it is often called a supervolcano. According to the Natural History Museum in London, this means it has the ability to produce a magnitude 8 eruption on the Volcanic Explosivity Index, releasing more than 1,000 cubic kilometers of material. In order to put this into perspective, the eruption of Pinatubo in the Philippines in 1991, which is widely considered to be the most powerful volcanic eruption in living memory, received a rating of 6 on the Volcanic Explosivity Index. This means that it was approximately 100 times smaller than the standard for a supervolcano, as stated by the Natural History Museum. So, should we be worried? Will Yellowstone erupt in the near future? Chapter: Is Yellowstone about to erupt? There have been a number of reports in the media claiming that Yellowstone is about to have an eruption. They assert that the impending eruption of the supervolcano is inevitable due to the fact that the volcano's most recent eruption occurred 70,000 years ago. Yet that is not how volcanoes operate. Michael Pollan, a geophysicist and the scientist in charge of Yellowstone Volcano Observatory, told Live Science in an email that volcanoes do not work on timelines. Maybe the most popular misconception about Yellowstone and about volcanoes in general is that they are dangerous. They erupt when there is sufficient eruptive magma under the surface and enough pressure to induce that magma to climb. According to Pollan, many volcanoes go through cycles of activity and inactivity. Most of the time, a volcano's activity is a direct result of the magma supply. Some volcanoes appear to have frequent eruptions, but this is due to a relatively steady magma supply. Consider Kilauea in Hawaii or Stromboli in Italy. So where does the notion that Yellowstone is overdue for an eruption come from? I believe the overdue concept stems from the concept of earthquakes. Pollan explained, earthquakes develop when stress builds up on faults, and in many areas, this tension builds up at rather steady rates due to, for example, plate motion. With this, you may expect earthquakes to occur at somewhat regular intervals. It is of course more complicated than that. There are numerous elements at play. Nonetheless, because of this, it makes more sense to state that a fault is overdue for an earthquake. Pollan further added that a variety of tools are being used to monitor. We monitor the temperatures of some thermal features, which are not indicators of volcanic activity, but rather of the behavior of specific hydrothermal zones. We examine overall thermal emissions from space, gather gas and water samples to analyze chemistry over time, and monitor stream river flow and chemistry. But what about the rare gas that indicates magma activities? Chapter: Rare gas. Helium is an inert gas that can be used to trace magmatic processes. Helium has 2 major isotopes: Helium-3, which is held deep in the Earth's mantle after being trapped during the Earth's formation, and Helium-4, which is formed by radioactive decay of uranium and thorium, 2 elements widely present in the Earth's crust. Magma erupts from the mantle, bringing part of the trapped 3He to the surface. When discussing the ratios and petrol samples, we utilize the air ratio, the Ra, as a baseline for comparison. If gas has been held in the Earth's crust for a long time, it will most likely contain very high concentrations of Helium-4 relative to Helium-3, and the Helium-3-Helium-4 ratio will be low, giving it a lower Ra value. A gas sample collected from an erupting volcano, on the other hand, will most likely include more helium-3 compared to helium-4, and the ratio will be high, indicating a higher Ra value. To make things easier, we express the Ra value of air as 1. Simply explained, a high Ra indicates that the petrol has a magmatic origin. A low Ra indicates the absence of a magmatic source. Years of research into Yellowstone's thermal zones have revealed that gas in certain areas is inextricably tied to the magmatic system. The gas from mud geysers fumarole in the mud volcano thermal area has the highest helium-3 helium-4 ratio of any feature at Yellowstone, up to 17 Ra, while nearby thermal zones have degassing features with Ra values greater than 15. Similarly, the helium-3 and helium-4 ratios in petrol from various features in Yellowstone's Gibbon Geyser Basin on the Caldera's border are quite high, but the greatest Ra value is 12.6. Both of these thermal locations have acidic waters with significant sulfur contents, and both include superheated fumaroles, where the temperature of the gas escaping the ground is higher than the temperature of boiling water. Thermal zones near Yellowstone Lake and other thermal features in the park's southeast have relatively low Ra values. These low ratios suggest more helium-4, which is the isotope of the gas contained in the crust's rocks. The Yellowstone magma system's heating has caused a large amount of this type of helium to be released from the crust, although the source of this gas is not the magma itself. Chapter: Signs of Catastrophic Eruption. Therefore, what signs might point to a catastrophic eruption? Poland has said that having thousands of earthquakes in a short period of time, with many felt events, would be noteworthy, as long as it was not an aftershock sequence from a tectonic event. However, this would be noteworthy. This seismic activity would need to be accompanied by fairly significant ground deformation of tens of centimeters over the same short period, park-wide increases in geyser activity, and thermal gas emissions, since the ground moves up and down by a usual amount of 2 to 3 centimeters on a yearly basis, and there are typically around 2,000 earthquakes that occur in the region each year. It would have to surge well above these normal background levels. Yellowstone is currently in a very stable state and has not exhibited any extraordinary seismic activity in recent times. But if the volcano were to erupt, the repercussions may be extremely severe. Volcanologists have indicated that the complication about which they are most concerned is wind-flung ash, which has the potential to cover an area that is 500 miles across with more than 4 inches of ash. Experts estimate that this will result in the short-term ruin of Midwest agriculture and the clogging of scores of watercourses. According to the Department of the Interior of the United States, the bordering states of Montana, Idaho, and Wyoming that are closest to Yellowstone would be affected by pyroclastic flows, while other locations in the United States would be damaged by falling ash. Poland went on to say that the impacts would be felt well beyond the borders of the United States. If there was a really massive explosion eruption, it may affect the entire climate by spewing ash and gas into the stratosphere, which could block sunlight and drop global temperatures by a few degrees for a few years. Thank you for joining us as we investigated the intriguing and perhaps disastrous finding of helium gas in Yellowstone National Park. While this gas could be a hint of an impending supervolcano eruption, there is still a lot we don't know. We hope you enjoyed this video, and remember to subscribe to our channel for more information on the most recent scientific discoveries.